Anybody know who this is? I don't think he's grateful for being dead. This is Robert the Bruce. This is the skull of Robert the Bruce. In anthropology, I've got to tell you that I interact with people who, and I'm one of these people who feels skulls to try to figure out what's going on with them. And to make the transition from genetics to traditional anthropology and back, this is quite a challenge. I'm going to try to put these things together for you to the extent that I can, because these are two different ways now that we have of looking at the past. The traditional way, feeling the skulls, leads to a lot of conclusions about what's happening in the recent past in human populations. So, for example, this is a chart of femur length, the length of your thigh bone, versus time, where here, in opposition to almost all of my slides, here I've got 0 at the left side and 10,000 years into the past on the right side. You'll see that I make these negative most of the time, so that the past starts at the left and comes to the present at the right. What do we got here? We've got essentially a chart that's showing no change to the extent that we can see. These are the regressions. This is a chart that shows brain size in the same population. Now, this is the population of southern Africa. This is the very tip. This is the ancestors of today's San populations. What's happened to brain size is that it has shrunk, and this regression is males and this regression is females. It's shrunk over the last few thousand years. Brains are shrinking. Southern Africa is in no way unique. I put it first because I wanted to make that point about body size. Brains are shrinking, the body is not changing in size. And also to make the point that this is worldwide. Here's Europe. Europe, this is endocranial volume means in males on the top and females next. The only disjoint here in this distribution is I don't have a sample of Roman era females to go in the spot. What happened? Early Upper Paleolithic people who lived 25,000, 15,000 years ago, had bigger brains than Neanderthals. A lot of you who know anthropology have heard Neanderthals had bigger brains than us. It's true. Neanderthals did have bigger brains than us, but they didn't have bigger brains than the people who followed them in Europe. Those people's brains were expanding until about 10,000 years ago when they started to shrink. The shrinking that's happened since 10,000 years ago, they've gone down in males and in females by about 150 cubic centimeters. If we went down by another 150, we would be Homo erectus sized. This is a big change. The standard deviation in endocranial volume, this measure today, the standard deviation in this is about 87 cubic centimeters. So we've changed by almost 2 standard deviations. Other stuff has changed too. Here's the thickness of the skull. This is simple. You put the caliper on the inside and the outside, you measure the thickness. Thickness has reduced. Our skulls have gotten more gracile. And if you study 10,000 or even Bronze Age era European crania, this is Europe, you'll notice that they're much more robust looking. Robert the Bruce was no exception in his population. That was a skull that had some rusticity to it. Coincident with this change in brain size has been a change in the ratio of the length to the breadth. This ratio is one that students don't study very much anymore, but that used to be what people really knew about humans, the cranial index. You would go around with a caliper and you measure people and you tell them about themselves. Oh, there's a famous part of On the Town where the museum lady is, oh, you're dolichocraniocephalic. It's exactly what this is. Cranial index. Bigger cranial indices mean that the head's broader compared to its length. Smaller cranial indices mean that it's longer compared to its breadth. So the head changes in shape. Now, why did I show you this old-fashioned measure of human variation? I'm showing you this to show you that it's changed a lot. The heads have gotten broader. Why have this changed? It's probably changed this way, I think, although I can't prove it, because the heads have gotten smaller. It's gotten smaller, and it's affected the length disproportionately. But the interesting thing about it is that in the olden days, 150, 100 years ago, this was the logic of human race differences. Why did people care about the long heads? because it was the invasion of the Longheads that explained the superiority of the Nordic races. We don't talk about the Nordic races anymore. We don't talk about the invasion of the Longheads anymore. This didn't happen. It was completely fictitious. But the measurements are still there. This is something that has changed in recent human populations. This change was recognized by Franz Weidenreich, who was known as a great anti-racist in his day, but also was the person who studied Peking man. That's why he was famous. And this is a chart that shows Sweden and Denmark head indices in two samples, Neolithic, that's early farmers, and modern day. And what you've got is a change in the average going from lower to higher, and in the next slide of Swiss, it's more evident. These are Roman era, 5th to 8th centuries versus 19th century. The cranial index changed. This is evolutionary change in the skull. Now, when we talk about genetics, we can look at genes that have changed in frequency in recent times and infer something about their history. When did this mutation happen? How fast has it spread? That's something that tells us a tremendous amount more information, in a sense, than this kind of information. And yet, these people, they were buried in the ground at that time. So they tell us a kind of information that genetics can't. The challenge that my lab works on is, how do you connect these things? Oh yes, endocranial volume also decreasing in China, and teeth are reducing in size. Recent evolution is real, and it's stuff we can see by looking at archaeological samples.
Shown from different perspectives above is an 8-centimeter high carving of a human face on mammoth ivory that has been dated to 26,000 years ago. A number of human likenesses carved, like this one on mammoth ivory, have been found in Central Europe, but none so intricate. The object shown here is the oldest portrait of a human yet discovered. It shows exquisite details of the subject, including eyes, hair, mouth, and expression. According to anthropologists who studied the skulls of the humans of this period, they had bigger brains and more robust skulls, as well as heavier brow ridges and jaws, and thicker noses. These traits are typical of archaic skulls, as seen here. The average prognathism in the Paleolithic samples is also greater than in modern populations, and probably has a lot to do with the much larger teeth humans had prior to the Neolithic farming revolution. Other art objects from around this period also showed the early Europeans represented with straight hair,